the last type of equation that we're going to see without really a context is going to be an equation where we have exponentials and logarithms present at the same time. And so what do? Well, there's no exact method I can dictate to you, but what I can say is generally you have to work from outside in, right? You have to get rid of the outside stuff to kind of like an onion, like peel away the layers to get at x. Okay, so in this first type where we have natural log of 3 plus 5 all to the power of x is equal to 7, I am going to need to get rid of the natural log, and then after that I can get rid of the 3, and then I can finally address the term that has the x in it, the 5 to the x. Okay, so how do I get rid of the natural log? Okay, I'm trying to think like I can't just divide by a log, right? So 7 divided by an ln is something interesting that I have no idea what it could ever be. Natural log is a function. How do I undo a function? Well, with its inverse function. So the inverse of natural log, if you is an exponential with a base e. So remember, you could write this as log base e of 3 plus 5 to the x is equal to 7. Okay, well, to get rid of the log, switch it to exponential form. So I'd have e to the 7 is equal to 3 plus 5 to the x. It feels uncomfortable, it feels icky, but we can still work with this. E to the 7 is just a number. You can put it in your calculator if you wish. Okay, so we're trying to get at the x, right? We're trying to solve for x. So move the 3 over. E to the 7 minus 3 is equal to 5 to the x. And then lastly, to get rid of the base of 5, this is where to undo an exponential, I need to use a logarithm. I need to convert it to log form. Okay, so then I'd have, log base 5 of this is equal to my exponent. So then the log form would be exactly what I dictated, log base 5 of e to the 7 minus 3 is equal to x. Okay? And that seems really gross and awkward. It is gross and awkward, and we could find its value totally with a calculator via change of base formula and whatnot. Okay? Now, this problem, we were given it as a log equation, so we should check our answer. Okay, so we should check. Now, checking it is going to be really weird because I'll have natural log 3 plus 5 to the log base 5 of e to the 7 minus 3, all in there. And I want to check that that is equal to 7. Well, the log base 5 and base of 5 in the exponential will cancel. And then I'll have e to the 7 minus 3. Okay, so I have natural log of 3 plus e to the 7 minus 3. The 3's are going to cancel. And then the natural log and the e will cancel. Same base, so base of the log matches the base of the exponent, and I'd be left with 7. So this one does check. So we can leave it as our answer for this is log base 5 of e to the 7 minus 3. Gross, I know, but it is what it is. Next example, 4 log of x. Okay, so I have to, again, I want x, but that's buried behind a exponential of base 4 and a logarithm. Okay, again, work from outside in, so I need to get rid of the 4. How do I do that? It's in exponential form, converted to a log. So I'd have log base 4 of 3 is equal to the exponent, which is log x. Log base 4 of 3 is equal to log of x. Okay, I still want x. X is buried behind a logarithm. How do I undo that log? I can't divide by a log. Never ever divide by a log. Okay. Instead, switch it from logarithmic form to exponential. So this base is base 10. So it'd be 10 to the power of log base 4 of 3 is equal to x. Again, ugly, weird, yup. It's going to work though. And the last thing we should do is check our answers. And I'm going to tell you, I'm not going to go through it here, but it will check. All right. So these equations that we saw, they have exponentials and logarithms mixed in together with them. And so really the way that we approach solving these is really trying to get rid of the stuff on the outside, well, wherever x is, get rid of the stuff on the outside of x as much as possible, term by term, or function by function, okay? And then our answer, it's gonna look messy, but it works, all right? So this is the last really equation type that we're gonna see. The rest are gonna be applications.